right, let's review some factoring techniques that will be incredibly useful to us. So the first one is actually not always used. Some people just prefer not to have to use this one. It seems complicated to recognize it. However, in certain circumstances, if you do recognize it, it will save you a lot of work. So this is where you have a single term that has been squared. Okay, and if we FOIL it out, we can get the formula for this. Okay. And you notice the only difference between these two is, of course, the sign change on the middle term. So how do we do this? I look at the first term and I say, is it a perfect square? It usually is. And then I would say A is whatever its square root is. I look at the last term and say, is it a perfect square? If it is, that's what I call B. Now the interesting part then is the middle term. Okay, now obviously this one has a plus sign, which would translate to a plus in the factorization. But mostly I'm interested in the 6. Okay, so the middle term is always multiply A times B and then times an extra 2. So x times 3 times 2 does in fact equal 6x. So this must be whatever my A was plus whatever my B was, quantity squared. And again, the plus is because that's what was written there. All right. Now, some of you are saying, I knew how to factor that a different way and it was a whole lot quicker. And I have no doubt that you could do that. I mentioned there were circumstances where it would help. Okay. We are going to learn another way to factor this next problem. But with numbers as big as 16 and 49, let's just say it would be a beast. Instead, I say, hey, 16x squared is a perfect square. Its square root is 4x. And 49 is a perfect square. Its square root is 7. If I multiply those together, 4x times 7 times an extra 2, I get the 56x in the middle. Okay. All right, sweet. And lifting that minus sign from the middle then gives me the factorization. All right, our next technique is one of the most important techniques of all of pre-calculus. It is called a difference of squares. Okay, so its name is very descriptive. It is literally a difference of two perfect squares, a squared minus b squared, and it will always factor as a plus b times a minus b. All right, so this one, all right, I clearly have a difference of two squares. The square root of the first one is x. The square root of the second one is 3. No, you don't have to actually write that part down. So it must be x plus 3x minus 3. Okay. Now you may be looking at the next one and saying, but those are not perfect squares. Correct, because you forgot the first rule of factoring. Before you try any of these other techniques, say, is there anything that I can factor out of every term? And in this case, I can factor out a y. And then the part that's left is in fact a difference of squares. Okay, it'll be 4x squared plus 9 and 4x squared minus 9. But we're not done. Now a sum of squares will never ever factor further. But this is once again a difference of squares. So it will factor even further as 2x plus 3, 2x minus 3. Also, please notice that these other pieces kept on coming along for the ride. Once I have them factored, they stay. Okay. So don't forget to write them, even if you're not actually focusing on them at that particular point in time. All right, now when I said factoring, this is the kind I bet you were all thinking of. This is factoring a monic quadratic. Monic means nothing is in front of x squared. It will factor as x plus something times x plus something else. And how do we get those two somethings? In this case, I called them s and t. I need s times t to always multiply to the c, and s plus t to always give me the b of the quadratic. In other words, this first one, I need two numbers that multiply to 6 and add to -5. And yes, you have to keep the negative signs. All right, well, multiplying to 6 is 1 and 6 or 2 and 3. Okay. Adding to 5 would say 2 and 3, except for I need negative 5. So it must be x minus 2, x minus 3. Okay. Next one, multiplying to negative 8, adding to negative 2. Well, multiplying to 8 is either 1 and 8 or 2 and 4. The fact that it's a negative 8 means 1 is negative and 1 is positive. And in order to add to a 2, it must be a 2 and a 4. Okay, I choose which one is negative so that when I add them, I end up with a negative 2. Okay, this is all done in your head, by the way. Okay. But it is quite a bit of a process in that head. So this time I'd be looking for two numbers that multiply to 12 and add to 8. So multiplying to 12 is 1 and 12, 2 and 6, or 3 and 4. The fact that it's positive 12 means either both numbers are positive or both are negative. But since they're adding to a positive number, they're both positive. And the set that adds to 8 is this middle set. So it must be x plus 2, x plus 6. Okay. By the way, notice this technique I have of just writing down all possible combinations that multiply to the number saves me a lot of guessing, saying, oh, what could the number be? These are the only ways that I can get a multiple of 12 out of two numbers. So if none of them add to 8, I would say it didn't factor. But one of them added to 8, so that's how it factors. All right. Factoring by grouping. First of all, this only works with an even number of terms. And specifically, more than 2. In practice, this usually means we need 4 terms. Okay. Why? Because I'm going to literally group these terms. Okay. And if there's only 2 of them, the groups are really boring. Okay. All right. Now, it's like you're covering up the second set. Okay. You can't see my hand though, so you can't see me covering it up. Cover up the second set and just focus on the x cubed minus 3x squared and say, what do those two numbers have in common? Well, they have an x squared. And after I factor that out, I'm left with x minus 3. All right, plus, don't forget the plus before we move on. The next one, I say, okay, minus 4x minus 12. What do they have in common? And I say 4. All right, now I'm going to write something and then erase it. Okay, if I pull out a 4, I'd be left with negative x. Okay, minus 3. Oh, that's because I wrote this down wrong. Oh my goodness. That was supposed to be a plus there. Sorry about that. All right. Well, this is going to cause us a problem. Specifically, I really don't like that negative sign there. Okay, so there's kind of a rule for this second grouping. It is you should always factor out so that the remaining thing starts with a positive number. In other words, since it's a minus 4x, I will factor out a minus thing. In this case, I'll pull out a minus 4 and be left with x plus 3. Now, you can always do that part. This next part, you can only do if you will successfully be able to factor it by grouping. And that is if the thing that was left over, that is in the parentheses, was identical. Okay? It is identical. So I'm going to factor it out. In other words, I'm thinking of this as one term plus another term. And what they have in common is x plus 3. And if I pull out the x plus 3, what I'm left with, so this is gone and this is gone, is an x squared minus 4. And that, of course, I can factor further because it is a difference of squares. Okay. All right, another one. We will group it. Okay. Out of the first two, I can pull a 2x squared, and I'm left with x plus 3, plus. Then I look at the second grouping. I can pull a 5, and I'm left with x plus 3. And yay, these terms match. So I can pull out the x plus 3, so they're now gone, and what am I left with? 2x squared plus 5, which does not factor further. All right, now, we did factoring by grouping because it's going to help us with the next method. I call this the AC method. It is for general quadratics. It is called AC because the first step is literally to take A and C and multiply them. Okay, now this is not going to be a quick method like Monic Quadratics was. There's some work involved. All right, so A times C, and don't forget the minus sign with that C. 4 times negative 3 is negative 12. Now this part is going to feel a lot like the Monic Quadratic factoring. I'm going to say, okay, to multiply to 12, I can do 1 and 12, 2 and 6, or 3 and 4. Now, of course, it was really a negative 12, so one of each term would have to be negative. Okay, now if I make one of them negative, will any of them give me a negative 1 from my middle term? Well, 1 and 12, no. 2 and 6, no. But 3 and 4 would. Now here's the part everyone always messes up on. They want to then factor it based on that 3 and 4. But that's not what actually happens. Okay? First of all, in order to get a minus 1, it's going to have to be negative 4, positive 3. And where those show up is that I take the minus x that I had and break it apart as minus 4x plus 3x. Why did I do this? Because now I have 4 terms and can proceed to factor by grouping. So out of the first 2 I can pull a 4x and be left with x minus 1. Out of the second 2 I can pull a 3 and be left with x minus 1. The x minus 1s are in common and I'm left with 4x plus 3. And I was able to factor it without guessing and checking. I despise guessing and checking in any type of problem. Whew, all right, let's do another one. So I take 2 times 6 and multiply them to get 12 again. This time it's positive 12. And because they need to add to positive 7, all numbers will be positive. So 1 and 12, 2 and 6, 3 and 4. Well, once again, 3 and 4 are going to work. So I break up that 7x as 3x plus 4x. And no, it doesn't matter which order you write the middle 2 terms in. I factor by grouping. Out of the first 2 I can pull an x and be left with 2x plus 3. Out of the second 2 I can pull a 2 and be left with 2x plus 3. I can then pull out that 2x plus 3 and that leaves behind an x plus 2. Okay. All right, one more. 2 times minus 4 is minus 8. So 1 and 8 or 2 and 4, and because it's minus, one of each one would have to be negative. So to get to a positive 7, it must be negative 1 and positive 8. So that's what I break my 7x up into. Then I factor by grouping. I pull out an x. I pull out a 4. Then I can pull out the 2x minus 1 and be left with x plus 4. All right, one more factoring trick I'm going to teach you. That is a very special form that if this happens, this is kind of the only way to factor it. These are called difference and sum of cubes. Notice I said and sum because unlike with squares, cubes we can deal with sums. All right, they are exactly what they sound like, the difference and sum of cubes. They will be identical except for a couple sign changes. And it essentially is you just need to have access to the formulas. All right, so an example of each. Okay, in our first one, the cube root of the first term is called A. The cube root of the second term is called B. And I'm taking the minus sign in the middle to tell me I should be using the first formula. All right, so what is it going to be? My A minus my B, A squared plus A times B plus B squared. And just as a hint, this is a quadratic and normally I say, can it factor? But if you got it from a difference or sum of cubes, it will never factor. All right. One more. Okay, the cube root of the first term is x squared. The cube root of the second term is 4. Now both of those are also perfect squares, but I can't do a sum of squares. I can, however, do a sum of cubes. Okay. So x squared plus 4. Okay, all right, squaring my a, multiplying the two together, squaring my b. And this concludes our review of factoring techniques.